Day 4, Spam Email Detector using Scikit-learn. Today, we will be building a machine learning model that classifies email as spam or not spam based on their text context. By using techniques like text preprocessing, logistic regression, we will learn to transform raw email data into features that the model can interpret. The project demonstrates fundamental steps in text classification and equips you with the knowledge to build models that processes and interprets text data. So our first step is to get the data. For that, we will go to Kaggle. So you can go to kaggle.com, and if you don't have an account, please create one account. And I am going to say spam base UC Irvine. That's the data set I need. And the first one that comes up, I'll download that. I can download zip, and I will take that from my downloads folder, open it, and I have my spambase.csv file. I will take that and put it in my, let's open this and move it to my or open folder, and inside that I'll move this. I'll call it spam.csv for now. Can close this, don't save, and here create a new file, save it as day 4 dot py. So our first step is to import the libraries. So first let me type them out. Now let's go through each and every line. So first line is import pandas as PD, where we are importing pandas as uh, which is a data manipulation library, allowing you to load and manipulate data in a structured format like a data frame. Then we are doing from sklearn.model selection import train test split, which imports the train test split function from scikit-learn, which splits data into training and testing sets. Next, we are saying from sklearn.linear model import logistic regression, which imports the logistic regression model from scikit-learn. Logistic regression is used for binary classification problems, in which in our case is spam versus not spam. Next, we are saying from sklearn.metrics import confusion metrics, accuracy score, precision score, recall score, and F1 score. Now, this imports performance metrics to evaluate the model's performance. The confusion matrix generates a matrix that shows the performance of the classification. Then we have the accuracy score, which calculates how often the model's predictions are correct. Then we have the precision score, which measures the proportion of positive predictions that are actually correct. Then we have the recall score, which measures the proportion of actual positives that are correctly identified. And finally, we have the F1 score, which is the harmonic mean of precision and recall. Next, we have import Seaborn as SNS, which imports Seaborn, a library for data visualization. It is built on top of Matplotlib and makes it easy to create beautiful and informative statistical graphics. Finally, we have the import matplotlib pyplot as plot, which imports matplotlib's pyplot module, which allows you to plot graphs and charts such as the confusion matrix that we will do. So now next step, which where we will be loading the data set. So I'll say load the data set and split it into training and testing sets. For that, I'll create a variable data equal to pd dot, I'll use pandas to read the CSV file, which is what we named as spam.csv. So we have that, and then I'll say x, which is our feature set. So we don't need the column spam in there. So I will say data.drop spam access equal to 1. So what I'm doing here is I am saying that drop the column named spam from the dataset to create the feature matrix X. Now X will contain all the columns except the target column spam. This will be the data used to predict whether an email is spam or not. So where does that go into? Y? Y is the target variable, which is the spam column, which contains the binary labels 0 for not spam and 1 for spam. So the way you define it, you just say I want only one column which is spam. That's it. Now our next step will be splitting the data set into training and testing sets. So for that, I will call that train test split function, and inside that I will, so this splits the data set into training and testing sets, which will have, which needs arguments like x, which is our feature set. Next I need y, which is our target, which is spam above that we have defined here. And then I need to tell it what is my test size. So out of all the data that I have, I want 20% of the data to be test, whereas 80% of the data to be used as training data. And then finally, I have random underscore state equal to 42. Now this is setting a random seed ensures reproducibility. You'll get the same split every time you run this particular code. So that's why you need to set it to a particular random number. So which is 42 in this case. Now this will give me a bunch of variables, which is it will give me the training data, testing data, and training targets and testing targets. So that will be x underscore train, comma, x underscore test, comma, y underscore train, and y underscore test. That's the format that I'll get data out from this particular function. Next, we will be training the logistic regression model to classify emails as spam or not spam. So let me write that down. Train the logistic regression model to classify emails as spam or not spam. So how do I do that? So I'll say model variable equal to, which one am I using? Logistic regression. So I'll set that. Then I'll say model dot fit x underscore train. It takes that and it needs y underscore train, and y pred equal to model dot predict, and I'll pass x underscore test to it. So what happens here is the first line number 18, model equal to logistic regression. It initializes the logistic regression model. The model dot fit, it trains the logistic regression model using the training features, which is xtrain, and the training labels ytrain. Now, next step where we are making predictions. What we are saying is after the model has been trained, this line on line number 20, ypred equal to model predict x test. This line uses the model to predict the labels spam or not spam on the test set x test. The predicted labels are stored in the variable ypred. Now let's go and print the data. So this is optional, but I like to do it. Print x underscore test. So this will print my data out. Now move it up for our next steps. Our next step is to evaluating the model using the accuracy, confusion matrix, precision, recall, and F1 score that we have done. So for accuracy, or let me write a comment here, evaluate the model using accuracy, confusion matrix. I'll use precision, recall, and F1 score. So how do I do that? So I create a variable called as accuracy equal to, I'll say accuracy score, and pass it y underscore test and y underscore pred. So here what's happening is we are calculating the accuracy of the model, which is the percentage of correct predictions, both spam and not spam. So that's what it does here. Next I'll say precision equal to precision score, and it takes the same variable, so I can just copy this and paste it here. So this calculates precision, which is the proportion of emails predicted as spam that are actually spam, which is that is like true positives divided by true positives plus false positive. So next I need the recall score. So I'm going to say recall equal to recall score and pass the same things y test y pred. This calculates the recall, which is the proportion of actual spam emails that are correctly predicted, which if you go by function, it's true positives divide by true positives plus false negatives. Next I need F1 score, so I'll say F1 equal to F1 score and pass the same thing. So this one calculates the F1 score, which is the harmonic mean of precision and recall. It provides a single metric that balances both precision and recall. So this has its own things. Now next is I'll print all these out. So I'm going to say print F, and inside here first I'll print accuracy. So I'm going to copy this from here. Actually, let me just 1 2 3 4 precision, recall, and F1. You can also say accuracy, precision, recall, so we know what we are printing, and F1 score. So there you go. Next step is to visualizing the confusion matrix. So for that I will be using so let's say visualize the confusion matrix using Seaborn's heat map. And for that I'll create a variable cm equal to confusion matrix, and then inside that it takes the same parameters. So this generates the confusion matrix, a table that shows, it will show me 4 different sections. One is true positive, which is emails that were correctly predicted as spam. It will show me true negatives, which are emails that were correctly predicted as not spam. It will show me false positives, which in this case are emails that were incorrectly predicted as spam but were not spam. And finally, it will show me false negatives, which are emails that were incorrectly predicted as not spam but were actually spam. So to do that, I'll say sns dot heat map, and it needs 2 parameters. One is 3 parameters. One is cm anot equal to true, and then fmt equal to d. So here this line uses Seaborn to visualize the confusion matrix as heat map. Anot equal to true is what I'm saying is annotates the heat map with the actual values from the confusion matrix, and fmt equal to do where format equal to decimal is saying ensures that the values are shown as integers and not scientific notation. And then finally what I'll do is I'll give a title first before finally. I'll call it confusion matrix. This is the title on top of the plot, and finally I'll say plot show. So save it. Now I need to import some libraries like Seaborn and stuff, but The best way to do it is I'm going to open it and check if I'm in the right folder, and I can directly write python day4.py. It will give me some error, hopefully not, because depending on what libraries I have or don't have. So looks like I have all the libraries installed. Sometimes cborn is not there, so if you don't see it, you can pip install cborn. And or sometimes skikit are not skikit learn is not there, so you'll probably have to import those. So depending on which one you're missing, you can import those. And here I can see that first it got me all the data. You see here it picked up all the data from that data file, and it went through training the model, and it says the accuracy of the model is 0.91, which means 91% accurate. Precision score is 92%, recall is 87%, and F1 score is 89%. And then at the next line it tried to plot our confusion matrix, which has the true positives, true negatives, false positives, and false negative in the four quadrants here. That is our confusion matrix displayed here. I hope you were able to follow along. If you have any questions, let me know and I'll get back to you.